Hey YouTube, so in the previous video we introduced briefly some of the main data types in C++. In this one we'll be talking about variables. In a computer program we would be interested in storing data and using it throughout our program. This can be done by the use of variables. A variable, informally speaking, is a named region of the memory that can store a value, and we can access that value through that name. This name is called the variable's identifier. To create a variable, we use a definition statement. This can be done as such. So we can start with the data type, so int, and I'm just gonna call it I. And what this means mainly is that we're defining an integer variable I, and we can define for all data types. So let's define, for example, float f and a character c, and when the program is compiled, the compiler knows that we'll be defining a variable, for example this one, a variable named n of type integer. When the program is run, this variable will be instantiated, meaning that an object will be created for this variable here and will be given a memory object. The same is for all other variables. To define multiple variables, we can do as such. So I'm going to define two integers, for example, a and b. This mainly is the same as writing down int a and int b. So note that this is called the comment block. So everything in between the slash star slash won't be read by the compiler. It's the same as these two backslashes, but these two backslashes mainly comment out one line, whereas this comments out a block. So for example, if I want to remove this part from my program, I can comment it out as such, or I can use this comment block here. What won't work is actually writing something like this, for example. You can see here that it gives me a warning, and if I try to compile, it won't run. If I comment this line out, then you can see my program compiles and runs regularly. So now that we know how to define a variable, let's see how we can give these variables some values. To give a variable a value, or to assign it a value, we can use the assignment operator or the equals operator. So let's consider here the int I. We use its identifier and write I equal 5, for example, and let's print out this value. So let's say my number is, and then we can print I as such, and a new line. And now let's give I a new value, or assign it a new value of 40, for example, and my number is now I. So let's run the program now, and you can see here in the output that we defined I, we gave it a value of 5, and we printed that I here is 5. We assigned it a different value now, 40, and you can see now the number is 40. So in the example here, we defined a number, an integer I, and directly gave it a value of 5. We used two statements here. It would have been better, however, if we provided a variable with an initial value when we created it. This process of providing a variable with an initial value is called initialization. And in C++ we have three ways of variable initialization. The first one is copy initialization, and it mainly relies on the equals operator. So instead of writing two separate statements here, we can write them as one, as such. So what we do here is we create an object of value 5 and we create a variable I, and then we copy the value 5 inside I. This is why it's called copy operator and copy initialization. Compiling the program and running, we can see that the number value here is 5. The second way of initialization is called direct initialization, and mainly we can use brackets to do so. So what this does is that it directly creates I with a value of 5. This can be better than copy initialization, since we wouldn't have to copy the value, rather we would directly create it, and in a way it would help with performance for simple data types such as integers, for example. It won't make a huge difference, but for more complex data types this can be more performance efficient. So let's give it, for example, a value of 8 for it now, and let's compile and run, and you can see here that my number was initialized with a value of 8. The third way is called uniform initialization. Unfortunately, direct initialization can be used for all types of initialization, such as initialization of list of data, for example. C++11 added a new syntax called uniform initialization, which mainly allows us to have a more uniform initialization mechanism for different types, and this is done through the curly brace. So we can initialize a variable as such, and let's give it a value of 6 now, and we run, and you can see our integer I was initialized with 6 here. In case we leave it empty, then it automatically converts to a 0, and you can see here now my number is 0.